Hello, and a warm welcome to my presentation. My name is Akshay Maker, and I'm a DevOps fellow at Insight Data Science. Today, I'm going to talk about my project, which is titled Imagility, which seeks to convert imagination to reality. So, UK as a furniture company has been facing a surge on return on sales and loss of customer satisfaction. Now, that is happening because a majority of the customers are not making great purchase decisions when it comes to buying furniture and then realizing it does not fit well in the space. They are making those return on sales. This is happening more with college students because they can't decide how things fit well in the dorm rooms. And so, to solve this problem, Ukia is coming up with an augmented reality app which will help customers take the guesswork out of purchase decisions and help them make good purchases. As a first step towards solving this problem, the machine learning engineers at UKIA have built a model that converts 2D images to 3D images. My job as a DevOps fellow is to make sure that the model is available in production such that it is not only available and resilient, but also scalable and meets the SLA of 15 minutes of processing per image. How will this all work? For that, let me take you to the solution architecture, which explains the whole process end to end. So on the very left, we have a web application, which a developer of the UK app uses to upload 2D images. These are 2D images of any furniture items you can imagine, chairs, sofas, tables, etc. Once these images are uploaded, they are stored inside an S3 bucket. So this is the first form of storage of the raw input images. At the same time, a message is sent to DynamoDB, which is the status keeper of all the messages. So here is where we'll know what happened with each of the processing of the images. If it failed, we can always go back and retry the images. That's why we need a status keeper. So once the images are stored inside the S3 bucket, they then trickle down into a message queue. In this case, I'm using Amazon SQS. And from the message queue, each of these messages will get pulled into what I have here, which are EC2s inside an autoscaling group. So these EC2s have the models uh, ready to process these images, and each of the EC2s will pull the image messages from the SQS. The autoscaling group is designed in such a way that if we get a load of images in the SQS, the scaling group will automatically scale out or scale in. Now, remember my initial SLA parameter is 15 minutes, and hence I need to design my autoscaling such that no image breaches the limit of 15 minutes. For that, I'm using a metric called as the approximate age of the oldest message in the queue. So if a message tends to stick around in the queue without being processed for more than 240 seconds, my autoscaling group will automatically trigger another instance, and that will start receiving the message that was waiting in the queue. We will see more of this in action in the demo. But for now, let's imagine that the EC2s have processed the image. Once processed, all these images are stored inside another S3 bucket, and the S3 bucket will trigger a Lambda, which basically updates the status of processing in the DynamoDB. So it'll actually update the message as processed. It'll fetch the email address. So one more information which I'm seeking from the developer along with the input images is also the email address, because I want to know who was the developer who uploaded the image. So Lambda will fetch that email address from DynamoDB, and it will send an email back to the original developer who uploaded the image. To see all of this in action, let's now look at the demo. So here in the demo, I have my autoscaling group, which has two instances that are running. And the console of the SQS, the message queue, shows that there are no messages that are available right now. So let's act as a developer of the UK augmented reality app, and let's choose some files, some chairs that we want to convert into 3D. Uh, let's go ahead and upload those images inside the system. And here I'm also going to specify the email address because I want to tell the system, hey, this is who I am and this is who uploaded the images. Now, once the images are uploaded, you can see there is an input bucket which stores all the messages. So once I hit refresh, you can see all these images have started coming in. Subsequently, in the DynamoDB as well, which is our status keeper, you will see I have the email address and also the file status, which is processing in this case. Once again, I'll go over to the SQS message queue console, and after hitting refresh, you can see the message count has increased to 11. And after some time, once I hit refresh again, the count decreases to 8. So in this case, it indicates that, hey, the EC2s have actually picked those messages from the queue. You can see 2 EC2 instances are still running. And I have a CloudWatch monitor, which in fact here shows a spike once to indicate that, yes, the EC2s have indeed pulled on the messages and they are reading it. After a while, there are only 2 messages which are left in the queue. And remember the SLA of 15 minutes. So we want to process these messages within that time limit. So here on the top, I actually have a dashboard that is tracking the approximate age of the oldest message. And for demo purposes, I have set the alarm to trigger when a message rests in the queue for 60 seconds. So here you can see the alarm is actually triggered. And once the alarm is triggered, it sends a request to the autoscaling group. Uh, Let me just refresh it here. And now we can see, yes, there is another instance which has been initialized. And now this instance will in fact query the message queue, and it will start reading those images and start processing them. While this is happening, let's also look at the steps after the processing has happened. So I have a processed images ukia output bucket, where if I hit refresh, now you can see there are some binary voxel files which are generated. This in turn triggers a Lambda function, which will then send an email. So let me just open the email. And here you can see, oh yes, I have received 9 email from the Lambda. And here I have the links of each of those output images, which are processed by the model. So moving on, let's talk about the DevOps challenges. So, designing the workflow of the whole process was a challenge in itself. But then, more importantly, I would like to highlight 2 challenges which I faced. One of which was to make the model available and then use scale in and scale out to meet the SLA of 15 minutes. I think that was the crucial challenge. To solve that, I used auto scaling on uh, approximate age of the oldest message. That was the metric which was used in SQS. And then the second one was to make the model resilient. So what happens if the model fails, or if the EC2 itself that was hosting the model gets terminated? So I tested that. I tested both the scenarios, EC2 failure and CPU utilization, using a tool called Gremlin. And my auto scaling group was able to survive and uh, showcase its fault tolerance, because if the system was taken down, another EC2 instance was born in its place. Now I had only 3 to 4 weeks to develop this project, and if I had more time, I would definitely focus on greater resiliency using a chaos engineering tool like Gremlin. So Gremlin allows uh, a lot of other processes wherein it can take down packets, it can spike up CPU utilization, it can spike up disk usage, memory usage. So all those things, I think it really is important when we talk about resiliency. And so I would build in greater resiliency, and then more robust monitoring, because right now I have the default CloudWatch monitoring on each of the AWS managed services which I'm using. But then uh, understanding to the depth of, hey, what's happening inside the EC2, what uh, monitoring should I build around the model itself, so that I can monitor it. So tools like Prometheus can help in this case, or Datadog has a nice application wherein we can impose some monitoring at the application level. So that would be a good next step. And finally, this is a little about me. So I'm Akshay Ambekar, and I always like learning new things. I recently just learned how to make perfect soft-boiled eggs for ramen. I really love ramen, and if you'd like to know that, I would be the perfect person to reach out to. Besides that, I'm also a musician. I love playing, composing, and teaching music. I've been playing music since I was 5 years old, and my favorite genres are blues, progressive, fusion, and rock. I also love exploring new places and meeting new people and embracing their culture. And so far, I've traveled to 7 countries, and I would love to travel the world one day. So that's my mission. Again, thank you so much for being a part of this presentation and dedicating your time to allow me to walk you through my project. Uh, Thank you.